Namaste everyone. Namaste everyone. This is Adarsh on the other side. Thank you for being present. Today we are here at the program organized by India Academy. So India Academy is being set up with the purpose of grassroots mobilization of teachers and academicians and in all subject areas with the goal of strengthening India's education system. Today we are here for the talk titled Indian Imprint in Modern Theoretical Physics from Cosmology to Quantum Gravity. India has always been a global leader in various research frontiers since time immemorial. This has also been the case in the last century or so in theoretical physics, where Indian physicists have made groundbreaking contributions to the physics of the tiny to that of the very large too. But unfortunately, many of these heroes have somewhere forgotten in mainstream India. And while their work is highly regarded in the research community, the general Indian today is not aware of these greats, sadly. We have with us the guest of today's program, Om Trivedi ji. Namaste, Om Trivedi ji.
जी नमस्ते।
So, we have with us Oem Trivedi ji, who will shed light on how the Indian heroes contributed massively to 21st, 20th, and 21st century theoretical physics, despite facing incredible hardships of various kinds, and would also relate how exploring the beauty of theoretical physics, especially in cosmology, is ingrained in our ancient Sanatan culture as well. So let me tell you about Om Trivedi ji. So Om Trivedi ji is a fellow of the Royal Astronomical Society and a research associate at the International Center for Space and Cosmology at Ahmedabad. His research interests span early universe cosmology, a variety of dark energy theories, cosmological singularities, black holes, and the intersections of all this with quantum gravitational theories. He is also a part of various international cosmology collaborations, including the LS Dark Energy Science Collaborations, Wide Field Spectroscopic Science Team, Cosmic Explorer collaborations, and the European Union's Working Group on Cosmology, Cosmoverse. He is also a member of the American Physical Society and the European Astronomical Society. His book, Quantum Gravitational Imprints on Cosmology, which he is co-authoring with Maxim Kolpov, will be published as the research monograph by World Scientific in their acclaimed advanced series on cosmology and astrophysics, where previous authors, including Stephen Hawking. He is also the recipient of multiple awards like the Pride of MP Award by Madhya Pradesh government, amongst other things. Welcome, Omji. So there was much to talk about you. So over to you.
Yeah, thank you so much for the kind introduction, Adarsh ji. And also thank you for Rajiv Verma ji for the invite for this talk. So I would like to share screen now. So I'll just do that right away. And I hope my screen is visible.
Mm, yes, it is visible.
All right, all right, all right. Thank you again. So thank you once again to Adarsh ji and Rajiv ji for the invite, and it's an honor to be here. And I hope today, you guys have a very good time, and possibly get to know more about the real heroes of our society, which have gone, possibly unnoticed in the last century or so. So let's start. So as Adarsh ji said, the talk of today is on Indian imprint on modern theoretical physics. And what I will be doing is that I will basically go with the chronology of a complete timeline. So we will start with the very early 20th century, and slowly we will build towards the modern day and how India has been doing in this field in particular from that time to the current time that we are living in right now. So let's start. So first up, what is theoretical physics, right? So physics has always been an empirical science. So whenever we talk about, physics, in the classical sense, we talk of Newton, we talk of Galileo, and we all have heard about the very infamous story of Newton and the apple, of course, right? And that typifies that, physics has always been about seeing things, about observing things, about doing experiments, and then trying to explain that, right? And that has always been the case since Newton. Newton's theories allowed us to explain what we saw about the universe. So Newton's theories allowed us to see, how, let's say, if I were to throw a ball, how will it go, or like what will be its motion and stuff like that. It also allowed us to understand, why the moon is attractive to us. It also allowed us to understand the solar system as a whole. So it had wide-ranging implications, but at the core, it was the fundamental idea that we wanted to explain what we saw, right? And by the 18th and 19th century, other fields of physics also developed. So Newton was not only involved in gravitational physics or like motion or or indeed calculus. His contributions were wide-ranging. He also developed the field of optics very strongly, which is basically the study of light. Then in 18th century, 19th century, the other fields which hold prominence now also developed. So these were thermodynamics, which is like the study of heat in a sense, and the field of electromagnetism, where we study the properties of the electrical force and the magnetic force. Uh, People like Hans Christian Ørsted, people like Lord Kelvin, and many others contributed significantly at this time, and we got to know some really remarkable revelations about the universe. But still, even in this time, physics was all about what we saw, right? It was about seeing things, it was about explaining things, it was about doing experiments. Then around 1864, James Clerk Maxwell came along, and he was a very good friend of someone named as Michael Faraday. Now, Michael Faraday is one of the most iconic physicists of all time. But very interestingly, he wasn't educated at all, at least in the conventional sense. So Maxwell was his very good friend, and he was a very good mathematician. And he saw Faraday's work, and he helped him by putting it all in a mathematical framework. Now we know that framework as Maxwell's equations, right? And those equations were a departure in more ways than one, because it was the first time we got to understand some properties which we were not directly seeing. Like, for example, Maxwell's work predicted that light has to have a certain speed. While at that point of time, there was this big debate on whether or not light has some particular speed, or does it keep on changing or stuff like that. But for the first time, mathematical equations, which were born out of Maxwell's work, were directly telling us that light as a whole has this particular speed. And that is something that eventually we came to understand very well in the context of vacuum and stuff like that. But not to digress on that regard. Now, unfortunately, till the 20th century, there was not much scope for Indian work, because like if I were to talk of Indian work in physics or stuff like that, we can talk about some very ancient times. We can talk about the times of Bhaskaracharya. We can talk about the times of Aryabhat, about Varamir, and people like them. But in this period of Renaissance, the European Renaissance, there was not much work which came through from the Indian frontier, unfortunately, because of obvious reasons. We were dealing with a lot of other stresses which were forced upon us. And then, by the start of 20th century, we had two remarkable developments, and those were the work of Einstein and the birth of quantum mechanics. So the work of Einstein told us, some of the most insane things that we now know about the universe, right? And quantum mechanics told us some very weird things about the physics of the smallest scales. So like how particles work on the smallest scales possible. And around this time, we finally started to see Indians contributing strongly on the frontier of modern theoretical physics. And with the work of Einstein and quantum mechanics, we can say that theoretical physics as a term was finally something which actually bore out of that work, because these two works, quantum mechanics and relativity, told us things about the universe which we still possibly cannot appreciate in its full beauty by experience. Because for example, relativity tells us about something known as time dilation, that time works differently for me and it works differently for someone in space, right? It could happen that if I were to go to space and a friend of mine is just sitting here in this room, then possibly in 10 years time I might only be 1 year older and he would of course be 10 years older. Now, we may not experience stuff like this to its full extent in our lifetimes, but the math of Einstein told us that this is true, and we were able to experimentally understand this and verify it to a certain extent as well. Similar things were told to us about quantum mechanics as well. Very weird stuff happened on that regard too. But finally, we started to see that it is not always true that we need to see something or feel something to 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 completely understand it in physical sense that we want to. And that was how theoretical physics came along. It provided us a beautiful intersection of mathematics and physics, and provided us a freedom to think beyond our imaginations at the time. So let's start off and let's firstly discuss the first beacon of hope for Indian physics as a whole, and that was Satyendranath Bose. So he was born on the 1st of January, 1884, and that is very fitting for a guy who, will born on the start of the year and started, the theoretical physics revolution in India as well. He spent much of his early years in Kolkata and then went to Dhaka. Of course, remember it was a time when Bangladesh and Pakistan were both part of the United India, and so of course Dhaka was also part of India. And he spent his early years in Presidency College in Kolkata as well, at the University of Calcutta as well, and then went on to Dhaka for his, first appointments as a lecturer, as a professor, right? He showed incredible, moments of genius right from his early childhood years, and he was, quite a magnificent student as well. Uh, then, in Dhaka happened possibly the most iconic episode of his life. So imagine this. You are a young professor, right? And you are teaching a class, right? It's only your second year as a professor, and you are teaching about possibly the most well understood theory of thermodynamics, which is Maxwell-Boltzmann statistics. So Maxwell-Boltzmann, as I just told about Maxwell, James Clerk Maxwell was this Maxwell guy, and Boltzmann refers to Ludwig Boltzmann, who many say was the father of something known as statistical mechanics, which you can understand as some extended form of thermodynamics. Now, imagine this, that these two big stalwarts created a theory which is known as Maxwell-Boltzmann statistics to understand how particles act in a gas, right? And now you are a young professor teaching this to your students, and all of a sudden you get this insane and serendipitous, motivation to just stop and stare at your blackboard. So you just keep on staring for like 10 minutes, then you tell your class that, hey everyone, class is over, and we'll meet in some days. Then you realize that Maxwell and Boltzmann were not completely right. So that is what happened with Satyendranath Bose. He was teaching a class, and all of a sudden, while teaching that class, he realized that the theory of Maxwell and Boltzmann, which has stood for a better part of 100 years by then, is incomplete. It does not account for all kinds of interactions that could happen in some gas. And later on, it turns out that he created his own theory of how particles interact in a gas, and those particles which obey his way of interacting in a gas or interacting in some, let's say, ensemble of or a collection of particles were known as bosons, of course, later on by Paul Dirac. Then came, some extensive collaboration with Einstein as well, in particular, alongside other greats like Louis de Broglie and Madame Curie. Einstein, in particular, was instrumental for Bose because when Bose found out about his new theory of how particles interact, at that point of time, his paper, which he had wrote on this topic, could not get published because at the time, most of the big publications, the big journals were written in German. And Bose, of course, did not understand German. So what did he do? He emailed, he, wrote a letter about his new groundbreaking work to the most known physicist in the world, which was Albert Einstein. And you can see that he was quite a courageous guy for doing that, because imagine this. I mean, you are basically sending a letter to the most busy physicist in the world, who's just traveling around the world giving talks and stuff like that, and you're hoping that he might reply. Einstein did reply, of course, because he's Einstein, and that shows you why he was such an enigma and such a legend. And he was incredibly impressed by Bose's work. He also pointed out some corrections in his work, and then he translated his work in German. And he told Bose that, I have translated your work, and you can now submit it. And Bose then said that you should also be a co-author in this work because you have pointed out some minute corrections. Then after that, they both submitted it, and of course that paper was published. And now, just as I was talking about Maxwell-Boltzmann statistics, that statistical theory of how particles interact in gases in some particular way, which is different from Maxwell and Boltzmann, is now known as Bose-Einstein statistics. And that theory, that Bose-Einstein statistics, again, had some math which predicted things which we could not see at that time. For example, it predicted about the Bose-Einstein condensate. So normally we think of three states of matter, right? We have liquid, we have gases, and we have, of course, uh, you know, the the other kind of matter. But some people also know about plasma, which is like a very hot, dense collection of particles. But the Bose-Einstein condensate is the other extreme of plasma, because this tells you about a very a very cool state of matter, which was predicted by their theory. But when Bose and Einstein got to know about this, they both of them were quite shocked, because they didn't expect something like that would even exist in real life. But yeah, their math was right, and they, eventually, many years later, after even the deaths of both Einstein and Bose, we eventually observed Bose-Einstein condensate in real life as well, which is now the most, cool state of matter, as you could say. Again, another interesting story from his life is that Bose actually never got a PhD, right? And that sounds very, very insane, but that is true. He got his master's, and at that time, it was enough to become a professor, right? That is how he started to lecture in Dhaka and had his big revelation. But after touring around Europe with Einstein, de Broglie, Curie, and others, he was suggested that he should now become a proper professor, not just some lecturer and stuff like that. And so Bohr applied for two places, and at that time it was, of course, a minimum requirement that you should have a PhD. Now Mr. Bose did not have a PhD, and that didn't matter because he had recommendations from Einstein, De Broglie, Madame Curie, and other big people. And in academia, recommendations can take you, of course, anywhere. And so instead of not having a PhD and being disqualified for that, Bose was made the head of the department at the University of Dhaka. After that, when partition occurred in 1947, he came back to Kolkata and spent the rest of his life there. He got numerous awards, numerous nominations, positions, and became the beacon of hope for Indian physicists. He was nominated for the Nobel Prize multiple times, but for some reason or the other, things didn't work out. But he has something which possibly no other, not many Nobel laureates have, and it is that if any student will study physics from this point onwards, he will of course always read about bosons, and in that sense his name is immortalized in academia forever. Now let's go a bit further, and this person is Meghnad Saha. He was actually a classmate of Satyendranath Bose as well. He was born on 6th October 1893 in Dhaka, and he came from a very humble beginning. So in the case of Bose, his father was an electrical engineer at that time, and at that time in India, which was being oppressed, being an electrical engineer, you can certainly understand that he came from a very good family. But that was not the case with Meghnad Saha. He came from very humble beginnings. He was not from uh, a very good household. He came from quite a poor family, and even after that, when he was in school, he was taken out of school because he started to participate in some struggles for freedom in India as a child itself at the time of his high school as well, because of which he was kind of like dragged back in his academic standings as well. Furthermore, he faced discrimination on the basis of his caste as well at that time, because that was quite prevalent. And even when he went to university, the discrimination continued, and it was both from Indian people and from the Britishers as well. So he overcame incredible adversities, and all of that culminated in an equation which now bears his name, the Saha ionization equation. So I told you about about relativity and quantum mechanics. These were two of the most groundbreaking ideas that physics had the pleasure to understand in 20th century. But the good part is that while relativity deals very strongly with stuff which is very large. So Einstein's theory of general relativity, for example, tells you about stuff like galaxies, it tells you about black holes, it tells you about very interesting stuff, but which is very far away from us. Like we live in a universe, of course, but that universe has multiple layers of complexity. So general relativity deals with the very big, while quantum mechanics deals with the very small. And one thing which was not very apparent in those early days of both of these theories was to how we can sort of like connect these two disparate ideas. And one of the first indications that these two ideas could be connected came through Saha's equation, because Saha's equation tells you how gases behave in stars. So while Bose's work tells you about how particles interact in a gas, for example, Bose's work completely dealt with very small particles. While Saha's work was also kind of like understanding on how particles and atoms interact in a gas, but it was much more on a larger scale, because that was also telling you how they interact inside a star. And that is important because, for example, our sun produces all its energy through a process known as nuclear fusion. And to understand that, you need to understand, both the physics of the very large, because we are of course talking about the sun, but you also need to understand the physics of the very small. And Saha, in a way, entangled both of these ideas from quantum mechanics, some ideas from quantum mechanics, and some ideas from relativity into his work, and that was beautiful. He also was an accomplished experimentalist as well, because besides his equation, which now bears his name, he also made an instrument to measure and weigh solar rays. And solar rays are like very energetic streams of particles which are sent from the sun every now and then. And he was a founding father. So we have institutions in India which now bear his name. He was instrumental in setting up various institutions, and he was also instrumental in setting up various collaborations of Indian institutions with those from abroad. So he brought your Cambridge, he brought your Oxford, he brought your Ivy League institutions to India to collaborate, and that was a big step, because we are talking about a time at which India has just been, on the verge of getting independence. But here is this fellow who is openly trying to, connect India with the rest of the world as soon as possible, and does not want it to lag behind in any sense. And that is incredible as well. And now, possibly the most interesting story on this slide. So, Meghnad Saha also became a member of the Lok Sabha. He also won the parliamentary election, and that too as an independent candidate. And this was the first election in the history of India. He won it in 1952, and the big thing is that he was standing against a very big business tycoon, right? And the business tycoon, of course, had loads of funding. But Meghnad Saha won the election with only 5,000 rupees. And even if you take into account inflation and stuff like that, it is not that big of a deal when you are considering that the other person has, like, lakhs or like crores of rupees even at that time. And the interesting part is that Meghnad Saha was writing books, right? And at that time, his election campaign started. And so many of his friends and colleagues said that, you need money in order to context elections in a proper way. And Saha said that I don't have that kind of funding. So instead, what he did was he contacted the publishers of his books and told them that, I'm doing this and that. And if you could give me just an advance of 5,000 rupees, that would be enough. And with only that amount of funding, he won that election very strongly by a huge margin of like 21%. And Saha went to politics only because he wanted to, bring about change in the educational frontier, because he had faced discrimination, he had faced adversities of incredible levels, and so he did not want others to face the same. And now let's talk about, just take a detour and let's talk about Ashutosh Mukherjee. Ashutosh Mukherjee was not a physicist. He was not, any kind of academician. In fact, he was someone who wanted to be a mathematician. But due to some constraints from his family side and from other issues, he could not become one. And one of the big constraints was that, the Britishers at that time did not, allow him to study math, even though he was very gifted at it. So what did he do? He studied law. He became a very acclaimed lawyer, and then he became judge, and he then became the vice chancellor of Calcutta University. And as I just told you, Meghnad Saha and Satyendrath Bose uh, were uh, were classmates, and so he cultivated this very incredible batch of students at Calcutta University, gave them all the means to succeed in their life. He even funded their foreign travels to the extent at which he could do, and so I felt that it is important to also remember this person who was the support of so many at that time, but possibly could not get the recognition that he always deserved. So yeah, one slide for Ashutosh Mukherjee as well. Now let's moving forward. Let's talk about Subramanian Chandrasekhar. So he was born on 19th October 1910 in Lahore. Again, this was a time at which Lahore, all of that was a part of India only, and he came from a very long line of intellectuals. So in fact, C.V. Raman, uh, who uh, who was the only Indian who had won the Nobel Prize for physics, when India wasn't like independent from the Britishers, and in fact remains the only Indian who has won the Nobel Prize while residing in India. He was his nephew, so he was the nephew of C.V. Raman as well, and his father, his mother, all his brothers and sisters, all of them were like incredible intellectuals, and so uh, he had this gift from his very early age. Incredible as he was, he wrote his first paper alone at the age of 19. And his paper was inspired because he had saw this lecture from Arnold Sommerfeld. So Arnold Sommerfeld is one of the iconic people of the quantum revolution, and he had just came to give one lecture in at the University of Madras, and a 19-year-old Chandrasekhar saw that lecture and he was very inspired. He worked for 3 months, and at the age of 19, alone as the single author, he wrote his first paper, and his paper was so impressive that that a professor at Cambridge got into contact with him. They sent letters to him, and they were like that if you want to do a PhD, please do it at Cambridge, and that's how he went to Cambridge for his PhD. There he impressed the likes of Dirac, Paul Dirac, Max Born, Edward Mill, and many others, incredible people who were working, in Europe at that time. So he worked with Paul Dirac. He also got to go to Göttingen and work with Max Born. He worked with Erwin Schrödinger as well. He also worked with Niels Bohr, and all of those incredible people that he always keep hearing about. All of them were impressed by this young, incredible student. But not everyone was as happy with him. So Arthur Eddington, curiously enough, is the person who experimentally validated Einstein's theory of general relativity, and he went to Africa to observe a solar eclipse, just like the one that we had a few days back. And by that eclipse, he was able to understand, see some properties of light, which was only predicted by then till relativity. And so, of course, he was a very big name. Now, the thing is that when Chandrasekhar was going to Cambridge on one of his travels, he was for a week, on the sea. So at that time, there were no airplanes. So the only way to, go to overseas was literally through the seas. And so when he was on that ship, he did various calculations, and he came up with this idea that if, let's say, a star has a certain mass, right? If it is a certain times more massive than our sun, then after a certain point, when it starts to collapse, so like for example, when it's nuclear fuel. So as I just mentioned you, all of the stars like our sun work on nuclear fusion, and so when its nuclear fuel starts to become very less, it starts to slowly die. So and then its death eventually could be of various scenarios. So it could become something known as a white dwarf. It could become something known as a red giant, or eventually it could become something known as a black hole as well. And these limit on the mass of the stars, which would eventually tell you about how it will end, was then known as the Chandrasekhar limit. And Chandrasekhar, as soon as he came to England, gave a talk about this at the Royal Astronomical Society, and the talk was very successful, and everyone was quite impressed again with him, but not Eddington, because Eddington just booked the second slot for the next day, and spent the whole of his time criticizing the work of Chandrasekhar, and it was not any constructive criticism; it was just a full-on diss. After that, Eddington also sent letters to other people to not publish Chandrasekhar's work, because he said that that work was just idiotic. Uh, The other big physicists at the time, people like Bohr, Dirac, and the others, which I just mentioned to you, were very supportive of Chandrasekhar's work, but not everyone was of the mood to come out in public in his support, because Eddington was such a big name. But eventually, Chandrasekhar's work got published and it became quite a, a revelation. Then Chandrasekhar got various opportunities. Of course, he went to Cambridge. He also had short stints at Oxford, at Niels Bohr's place in Denmark, in Germany as well. Eventually, he got an offer to be a professor at Yale University, which he did not take. Then he got an offer to be a professor at the University of Chicago. Again, he was not very much on board with the idea of becoming a professor there, but the president of the University of Chicago, Dr. Hutchins, was very adamant to have him in. And so, he accepted that offer and became a professor. But on his first class, there was another professor in the department who said that, people like Chandrasekhar should not teach these courses to white young students. And the director, Dr. Hutchins, who I just mentioned to you, came out strongly in support of Chandrasekhar and said that, that Mr. Chandrasekhar should be allowed to teach in all capacity. And Chandrasekhar was, in fact, the first guy who was not a white, non-American person teaching high-level courses at the University of Chicago. And he was an incredible teacher, and that is typified by this incident. So when Chandrasekhar was working, in Chicago, he also worked at the Yerkes Observatory. And so eventually, as he became more and more of a very big physicist, his teachings became, like a very small part of his job. And so he only offered some very advanced courses, and many a times nobody signed up for the course. Now he was teaching this course on quantum field theory and cosmology, something again which is about two very disparate fields of physics. And not many people registered for the course besides two students who were not Americans. There was this guy named as Yang, and there was this guy named as Lee. So now it was Chin Cheng Yang and Sung Dao Lee, right? Now, what would you do? Because you had to come 150 kilometers from the observatory where you are working every day, right? On the weekend to teach a class of only two students, and it is not very sure whether those people will also understand the nitty-gritties of your course, because your course is very difficult. But Chandrasekhar did not bother. He drove 150 kilometers every weekend to teach to those two students. And that class became very personal, because they were just discussing stuff after a certain point of time, and it became more about writing papers together rather than having just a simple course where a teacher is teaching his students for some exam. And eventually that is only the one class of all time where everybody won a Nobel Prize, because eventually Sung Dao Lee and Chen Cheng Yang both won Nobel Prizes, and the professor Subramanian Chandrasekhar also won a Nobel Prize. So what an incredible person. Of course, he had numerous positions across the world. In fact, he had some kind of a visiting position at every continent where humans reside. He got various awards. He got fellowships of the Royal Society. He got, of course, he won the Nobel Prize as well, and he ushered a new age for astrophysics with his work on black holes. Now we come to a very tragic part of our talk, which is about Vishweshwar Dutt. And as you would see, I have not put his photo because there is no photo available of this incredible person. There is no info available about his birth as well, so we don't know his birth date. But what did this guy do? So recently, a movie came out on John Robert Oppenheimer, which everybody has seen. It has won Oscars as well. But one of Oppenheimer's his greatest work was on collapsing stars. So something which Chandrasekhar was doing, like what would happen when a star runs out of its nuclear fuel and starts to collapse. So Oppenheimer's greatest work in astrophysics was on this topic only, and he and his student David Snyder worked out uh, how stars would collapse under their own gravity. And what if I told you that, like the work that these two did in 1939 was already done in 1938 by a very little known fellow at Presidency College in Calcutta named as Vishweshwar Dutt, because that is exactly what happened. Vishweshwar Dutt did his calculations on this topic in around 1937, 2 years before Oppenheimer and Schneider ever published their papers. And the only reason, again, he was not able to publish his work because at that time, most of the big publications were in German, and Dutt did not have someone like Einstein to write his papers again. And so his work was in obscurity for the longest time, and and of course, Oppenheimer and Schneider's work on collapse got published quite before him, even though his work preceded them. Now, what happened was that he wasn't able to do anything about this as well, because in 1939 he unfortunately passed away because he was being treated for hernia, and the doctors and the surgeons did some mistakes. And just due to a faulty operation, India lost one of its greatest young minds at that time. And the sad part is that we don't even have his photo. We don't even know what happened of his family. We don't even know, when he died. So that is quite tragic. But what we do know is that one of his uncles eventually found out one of his papers and sent it to a professor at Presidency College. Eventually that paper got published as well, and now, at least in the circles of gravitational collapse, uh, the process of collapse is now known as Oppenheimer-Schneider Dutt collapse, the OSD collapse. But still, it is quite sad that we do not have much information about this great person. Speaking of not having much information, let's talk about Suraj Narayan Gupta. So he was born on the 1st of December in 1924 in Punjab. Uh, he spent his early years in Delhi, so he migrated with his family to Delhi, and then he went to Cambridge and Manchester. So he spent the bulk of his early years of physics in the UK, and he developed quite an understanding of various aspects of quantum field theory at that time. But one very, again, saddening thing that I would like to share is that, this is the only publicly available picture of Suraj Nayan Gupta. We don't have any other pictures anywhere on the internet. And that is sad because this is one of the fathers of, the field of quantum gravity. I think most of you might have heard about Richard Feynman, but even, people in India who do work on particle physics don't know about who Suraj Narayan Gupta was, because this guy, concurrently and independently of Feynman, uh, proceeded to give something known as covariant quantization. So when we talk about quantum gravity, we want to understand the aspects of general relativity on the very small scales. So we want to understand this theory of the very large on the very small scales. And what we do is we try to quantize that theory. So by quantize, I mean that basically you would like to set up the whole theory again, but instead of being in the picture of the very big, you want to set it in the arena of the very small. And so, quantization at that time was something very new, and people were applying it to other theories like electromagnetism, like Maxwell's equations and stuff like that. And because of that, you had stuff like quantum electrodynamics coming up, for which Feynman won the Nobel Prize alongside Julian Schwinger. But uh, but Suraj Gupta was one of the first people who had thought that we can apply quantization to gravity as well. Of course, it wasn't a properly quantized theory because we still don't have a properly quantized theory. But at that time in 1952, trying to do something like that, that is completely incredible. And so more people should know about him. He did some incredible work on quantum chromodynamics as well, which is basically, how uh, how stuff happens inside the nucleus of the atom. He did incredible works on quarkonium as well, which is a very exotic type of element. He was a very private person. Now, I had to talk with Professor Wayne Repko from Michigan State University to get this info because there is no personal info about Suraj Nayan Gupta available anywhere. So he was a very private person. He had two children. He loved Indian food and cotton candy as well. So he apparently told Professor Repko once that he used to love eating cotton candy back when he was in India. So Gudiya ki Bal, and that is quite sweet because when you think of such a big faces, you won't think that someone like him would remember stuff like that years and years after leaving India. But but that just tells you that beneath all of these incredible personalities is still a human being. Now we talk about Prahlad Chunilal Vaidya. He was born on the 23rd of May 1918 in Junagadh in Gujarat, and he spent his early years in Bhavnagar. Then he went to Mumbai in TIFR, and so no, so he went to TIFR eventually, but he was still mostly connected to Gujarat at that time. Where they contributed extensively to the non-violent struggle for freedom in India, and that is quite interesting because he started to teach students trigonometry and other similar mathematical stuff on geometry. Uh, he started to teach undergrads, and again it was at a time when a PhD was not needed to start teaching these people. And uh, Initially, the college at which he was teaching was under the control of St. Xavier's College in Mumbai. But then, the royal family of Rajkot took control of that college, and he had some issues with the management. And so this courageous person went against the management of that college, who was from the royal family of Rajkot, and that was because he did not want to support the Britishers in any sense, and so he put his physics career on hold and instead started to contribute extensively in nonviolent struggles for freedom in India. He was very much inspired by Gandhiji, and Vishnu Vasudev Narlikar, who was and still is one of the most iconic physicists in Indian history in the last 100 years or so, talked with him and got him to Banaras. And when he was in Banaras, like Gandhiji was doing his unshin, and strikes were happening across the country. Prahlad Vaidya had his 6-month-old daughter and his wife with him, and he was only surviving on his savings from long back. But at that time, all of a sudden, he came up with this idea of the Vaidya metric. So a metric is a mathematical formulation to understand how certain celestial objects work in the theory of relativity. And as you can understand, it was quite a revelation because of course that metric, that equation now bears his name. And he explained how spinning black holes work out in these theories, and that was an incredible achievement. He of course had numerous positions, awards, and contributed everywhere. He had like collaborations from worldwide. And of course, also he had one incredible episode with Robert Oppenheimer. So in 1951, he wrote a letter to him about his paper, and Oppenheimer was so impressed that as he was one of the editors of a big journal at that time, he uh, he published that paper on his own. And so that is like incredible when someone like him appreciates your work to that extent. Then we have Amal Kumar Rai Chaudhary. He was born on the 14th September 1923 in Barisal. He was raised in Kolkata. He loved math since his young days, but he was not, in a position to take math because, of some issues at his home the uh, and with how things were there in Kolkata at that time. So he was forced into working on metals, which was never to his liking. So he was kind of working on condensed matter physics. And now I will tell you just one thing. I'll tell you just one story to tell how big of a person he was. Of course, he has one equation on his name, which is one of the most fundamental equations in general relativity, which is the Raychaudhuri equation. But I will just tell you this one thing. So when one of the students of Rai Chaudhary went to Cambridge for his PhD, uh, he uh, he had this chance meeting with two young fellows, right? So they were sitting there and they was like discussing some work. So one of the fellows was Roger Penrose. Who was a professor at Cambridge then, and there was the student of his in his office. So this student of Rai Chaudhary went to meet Penrose, and he introduced himself and all that, but nobody was paying much attention to him because they were like, oh, just another Indian. But then somebody asked him, who is your professor? And he said that my professor is Amal Kumar Rai Chaudhary. All of a sudden, the faces of Penrose and Hawking changed completely, and they were like, wow, what? So yeah, and the other person, as I just told you, was Hawking, who was standing with Penrose, and Hawking said that it would be an honor for us to meet Professor Rai Chaudhary once in our lifetimes because he is an inspiration to both of us. So Roger Penrose and Stephen Hawking took this person as an inspiration, and that should tell you everything that you need to know about him. Of course, he got numerous awards, positions, but never he had enough recognition either from the state government of Bengal or from the central government, and that is still something which is very sad. Now we talk about an incredibly sad episode, and that is of Inakal Chandi George Sudarshan. He was born on the 16th of September 1931 in Pallam in Kerala. He spent his early years in Chennai, and then he went to Mumbai in TIFR. So he had his postdoc years and the PhD years in Mumbai. After that, he went to Rochester to work with Robert Marshak, and then he worked with Julian Schwinger, who was one of the uh, the greatest physicists of 20th century. And his work with Schwinger and Marshak paved the way for something known as electroweak unification. So that is basically the theory in which the weak nuclear force, which is like, of course, the weaker of the nuclear forces, and which is like related with how nuclear radiation works out, was unified with the theory of electromagnetism. So the work of Maxwell and the others. So his work paved the way uh, in basically creating a framework in which you can understand electromagnetism and the weak nuclear force in one framework, and that was, of course, that is amazing. More amazing possibly is his work on quantum optics. He is, in a sense, the father of quantum optics, uh, and he gave this wonderful mathematical representation to understand quantum optics, which is the Sudarshan Glauber representation. But it is quite a controversial thing to even put Glauber's name here, because this representation allows you to understand both the particle aspects of light and the wave-like natures of light in one single framework, which is quite amazing. But uh, while Glauber got the Nobel Prize in 2006 for this exact thing, Sudarshan was overlooked for this. And not once, not twice, he was nominated for the Nobel Prize 9 times. And every time he was nominated, he was overlooked. In fact, he and his work was also intimately related with the standard model of particle physics, for which Steven Weinberg, Abdus Salam, and Glashow got the Nobel Prize in 1968, which is, possibly the biggest achievement in particle physics in the last century or so. But again, he was overlooked because in all of these works, at some level or the other, the person who won the Nobel only built on the work of Sudarshan. But Sudarshan himself did not ever get the Nobel. But that didn't stop him. He came up with the idea of the quantum zero effect, which is like, which is the notion that if you keep on observing a particle for long enough, you can do some very weird stuff with it. He was also instrumental in bringing about the idea of tachyons, which is, faster than light particles, which is something Einstein's theory of relativity does not appreciate. But he went even beyond that. Of course, he got loads of awards, he got loads of positions in India and abroad, and he spent most of his life in Texas. But again, he was not much appreciated either by the governments in India, right, or those from his parent state. But all of that aside, of course, this person deserved a Nobel Prize. Yeah. Then we talk about some more modern stalwarts, and we start with Jayant Narlikar, who was born in 1938 on 19 July in Kolhapur in Maharashtra. He came from a family of intellectuals. So I just mentioned about you to Vishnu Vasudev Narlikar. So Vishnu Vasudev Narlikar was his father, who was instrumental in the development of PC Vaidya, as we have just discussed. And his family was complete with these intellectuals. So like he came from a family of cosmologists, uh, as you can say. He went to Cambridge for his early career work, and there he worked extensively with someone known as Fred Hoyle. And Fred Hoyle and Narlikar actually proposed an alternative of the Big Bang theory, which we usually refer to as the beginning of the universe. The Hoyle-Narlikar theory is different, and it does not start off with a bang. Rather, it says that the universe is cyclic in a sense, and after each cycle, another new cycle starts, and like well, it is not about completely about cyclic theories. Rather, it is about the universe always being in a steady state. Uh, of course, his work, eventually this steady state theory did not gain much traction because it has been ruled out by some observations of the early universe. But still, it was an incredible theory, and for the longest time, maintained a strong competition with the Big Bang. But even besides that, he has worked on multiple aspects of quantum cosmology. In fact, he has been one of those people who has propagated this idea of integrating quantum mechanical aspects in cosmology directly, and he has won numerous awards. He got numerous recognitions both in India and abroad, and that is something which is certainly appreciated. Then we talk about another genius from Kolhapur, and his name is Abhay Ashtekar. He was born on the 5th of July 1949 in Kolhapur. He spent his early years in Mumbai, then went to Texas, and then, of course, he went to Chicago for his PhD under Robert Giroch, who is again, one of the the big people of the quantum revolution. And now, this guy right here is one of the founders of loop quantum gravity. Loop quantum gravity is is possibly one of the most famous theories of quantum gravity out there, and he independently found aspects of this work with Carlo Rovelli and Ted Jacobson. And his work on loop quantum gravity stands in direct competition with possibly the most famous theory that we have in physics right now, which is string theory. But his work on loop quantum gravity is still providing some stiff competition to string theory. In fact, uh, some aspects of loop quantum gravity are better understood than string theory. For example, loop quantum gravity can explain some properties of black holes uh, in a much better way than string theory, and in a much more relaxed sense as well, and that was also due to Ashtikar. Of course, he has numerous everything, right? He got numerous awards, recognitions, and currently he is in Pennsylvania. Now we talk about Pankaj Shantilal Joshi. He was born on the 25th of April in 1953 in Bhavnagar. And one thing I would like to say is that I've been very fortunate because he is one of my co-authors as well. He is a collaborator and a mentor for myself, and that is quite uh, and that is something which I would appreciate, you know, and, until I'm alive. He spent his early years in Bhavnagar and obtained his PhD under PC Vaidya, who we just discussed about, and then went to Pittsburgh for his postdoc. Now, the incredible thing that he has done is work on naked singularities. So Hawking and Penrose proposed, these ideas on black holes, and Penrose in particular proposed this notion that black holes have always got to be covered. So, like if you have seen those photos uh, of uh, of black holes which were recently taken up by observations some years back, so you would see that like uh, like there is this circle kind of thing around a black hole, and some people can call that thing as an event horizon, speaking very loosely, right? And Penrose proposed that black holes, or like singularities in space times, which are like points of infinite density, as you could understand, uh, are always covered by some kind of things, and so they're not naked. So like there is always a kind of event horizon, there is always a kind of covering which covers uh, a black hole or some singularity, and this is known as the cosmic censorship conjecture. This has never been proved, of course, because we are still calling it a conjecture, but the work of Dr. Joshi on this regard has been immense. He has been one of the biggest voices on naked singularities worldwide, and he has done some seminal works on it. In fact, uh, some classes of naked singularities bear his name, which is which are the Jamin singularities, the Joshi, Malaparina, and Narayan singularities. And in fact, the photos of black holes which were taken by the observations seem to also corroborate very well with the J-mean singularities as well. So it could just easily be possible that the photos which were taken of black holes were not actually of black holes, but rather of J-mean singularities. He has numerous awards. He has taken numerous positions across the world, and he is quite a celebrated physicist, both in Gujarat, in India, and also abroad. And that is quite an incredible thing. We talk about Thanu Padmanabhan now. He was born on the 10th of March in 1957 in Thiruvananthapuram in Kerala. He published his first paper at the age of 20, and that too alone. So he was like an early bloomer, similar to Chandrasekhar that we had just discussed, and he went to Mumbai later for his PhD and his postdoc work. He did some seminal contributions to our understanding of dark energy. So dark energy is that mysterious form of energy which is currently driving the expansion of our universe, and we do not have any idea about what it really is. And so Professor Padmanabhan's contributions on this regard have been immense. He has also worked on a theory of emergent gravity. So Professor Padmanabhan worked out, what would happen if we wanted to explain gravity on the smallest scales, not from the point of view of, let's say, quantum field theory, string theory, and all that, but rather from the point of view of thermodynamics. And he has been one of the most instrumental people on the theory of emergent gravity. Unfortunately, he passed away in 2021. But I was also very fortunate to have gotten a chance to meet him in 2019 and also discuss some stuff with him. He won numerous awards. He had like positions across the world, and in particular at Ayuka in Pune, and yeah, he was just an incredible person. And finally, we come to possibly the most like productive theoretical physicist in India at this time, and he is Ashok Sen. He was born in 15 July 1956 in Kolkata. He spent his initial years in Kolkata and then went to Stony Brook University in New York for his PhD. And he was inspired by Rai Chaudhary because he is a student of Rai Chaudhary. And the work of Amal Kumar Rai Chaudhary was so impressive to him that that was the only reason why he started to get interested in the theory of gravity. Like initially, he wasn't even interested in gravity, but he got interested in it, and it was only Rai Chaudhary that eventually told him to work in aspects of string theory as well, and also work on particle physics. And so he ended up in string theory. And as I just mentioned to you, string theory is like this very beautiful theory where it is said that instead of particles, right, the fundamental of everything is not particles but are rather very tiny strings, very incredibly minute strings which are even smaller than particles themselves. And the way in which these strings vibrate tell you how different particles are formed. So for example, if you consider some kind of a guitar, then you can plug its chords in various ways, and that will bring about various sounds. So in a similar way, string theory says that various vibrations of these strings, various types of these strings, give you various different forms of particles, give you various different forms of energy, and that is how all of particles are made, and that is how the world works out. So in a sense, string theory is a theory of everything. It is not only a theory of quantum gravity, and that is right. Uh, that is basically the position of string theorists. But of course, I'm not taking any side here. Now, what Dr. Seen has done is that he has done some incredible work on tachyons in string theory. So tachyons, as we just discussed in the case of Dr. Sudarshan, are particles which are faster than light. And there is a conjecture which bears Professor Sain's name, which is the same conjecture in string theory, which is based on how these tachyons condensate in a sense, but not digressing on that here. Of course, he has numerous everything again. He is incredibly well known in string theory circles. In fact, he is possibly one of the biggest string theorists in the world right now. And he is quite celebrated, both from an Indian perspective and a broad perspective. And in fact, even governments have appropriately respected his achievements. So, now to like summarize what to expect now. So Indians have led the way from the smallest to particles to the largest galaxies, and we have just seen that here. Of course, like even if you take our ancient scriptures, like like the Puranas or the Ramayana or the Mahabharata and stuff like that, then you would see that there have always been these hints of very incredible setups which are only just now being discussed. So, for example, this idea of time dilation, which is in special relativity, was there in Srimad Bhagavad Puran, right, which is on Sri Krishna. Mahabharata has this idea of multiple universes. Also, Srimad Bhagavad also has this idea of multiple universes. The idea of a cyclic cosmology is seen in various Puranas. For example, you can see uh, yeah, for example, you can see Varaha, where there is a complete description of the various cycles that have gone by in the universe, and which Puran belongs to which cycle. So in fact, our Sanatan culture and our ancient books have had these imprints of various exotic physics, which we are only now starting to appreciate and starting to investigate from long back. And now in the modern age as well, various Indians are leading the way in these regards. These people have moved beyond incredible struggles. So people like Chandrasekhar, people like PC Vaidya, people like Vishweshwar Dutt. These people, have moved beyond discrimination, beyond struggles of of independence, beyond every kind of family constraints and stuff like that, to produce stuff which we will always be grateful for. And that is something which should motivate the incoming generations of not only physicists, of not only mathematicians, but to every young Indian out there who is trying to make a change in this world and who is facing hardships. Because that just tells you that if you want to do something amazing, you need to go through various hardships. We have heard about people like Carl Sagan, Richard Feynman, Ryan Green. Any Indian kid out there who is interested in physics would have possibly heard their names. But I think now it is a time that people start to also know about their household heroes as well, and uh, and I think one important thing that needs to be start done on a la- on a larger scale is appropriate science outreach in India, so that not only do we start teaching our kids more about these incredible aspects of physics or science, but also about the people who have done incredible stuff from their own country and who are still doing incredible things out there. And I would like to end my talk with this note from Paul Dirac's book. So this was Paul Dirac's first book on quantum mechanics, where he gave his theory, where he kind of like unified quantum mechanics and special relativity in one framework. And that book ended with the note that new ideas are needed. And that note prompted Richard Feynman to pursue physics and to pursue particle physics. So I think I would also like to end on that note, and just say that of course physics still needs new ideas, even though Paul Dirac's book was in 1930s, but we are still as receptive to new ideas, to new people, and to new beginnings as we were then. And so on that, I would like to end my talk. I hope you all enjoyed it. I would again like to thank Dr. Verma and Adarji for the invite for this, and thank you so much.
Thank you, Omji. Thank you so much, Omji, for enlightening us. Now, I would like to request our audience, if someone has a question for Omji, he or
Yes,
she
yes,
can put it in the chat box,
yes.
or can raise their hand. So we will be taking questions one by one. So does anyone
Adarshi, I
have a
have a
question?
question.
Yeah.
This is Professor Anurag Mishra. Uh,
Yes. Yes.
am I audible?
Yeah. Yes,
Yes.
sir.
Yes. You are audible. So,
Okay.
if sir, if you can, start your video. Thank you.
I hope I am. Yes.
Yeah.
I have a question for Omji.
Mhm.
Uh, you have, given a long list of Indians who have worked really hard on this. And my query is that why we have stopped producing these kind of physicists during last 40 or 50 years now. Why it is so? Because I was a student around 40 years back during 84 to 87 in the undergraduation of physics honors, and then from 87 to 89 doing my masters in physics. And we have been taught these theories which have been produced by these physicists. But after that, once I have come into teaching profession and all that, during last 40 years, we have stopped producing these kind of quality physicists. Is there any specific reason?
Uh, Thank you for this question, Dr. Mishra. And I would like to say actually that for the last 40 years or so, there have been quite a few breakthroughs which have been, mitigated by people from India and particularly people of Indian origin. And that is the keyword here, because similar to Professor Chandrasekhar and people like him, various physicists who are now contributing immensely on various fields have actually migrated out of India. So for example, if you would, think about, CERN, right? So there are a lot of people who are on the top, positions in CERN, who are contributing as, the first authors in their works, who, who were born in India, but eventually they left India because of various reasons, right? And the reasons could be, related to pay and stuff like that, but that is not entirely true, because it is not only about payment or stuff like that, but rather it is about the kind of environment. Because many a times, if you want to do incredible research, or you want to, inculcate, world class aspects in your work, it could be a real possibility that there is not much appreciation for that kind of people in India. And so those people leave India and, eventually start to do incredible things. But by the time they start doing these things, they become a citizen of some other country. And so and so technically, for example, that person is now a European person, or some person with an American green card, and now that person is not an Indian. The other thing is that there are many Indians who are still doing great stuff in India. But the thing is that, people, like, that's why I mentioned it in my last slide, that, any kid who wants to, do something good in, like, physics, possibly knows about Richard Feynman, but they don't know about the people who are, doing good stuff in India already, because in India we don't have this system of, of a proper science outreach. So for example, we do have Doordarshan, like, for example, and Doordarshan has, interviewed Professor Ashok Sen loads of times. But still, if you were to ask someone, they would only watch documentaries from BBC, they would watch documentaries from, CBS, and those kind of portals. But we do not have that kind of active science outreach platform in India, at least till now. And so I feel that if we eventually start having that kind of platform here as well, then it would be apparent that there are people in India as well who are contributing on a very good global level still. But again, we just don't know much about them outside the circles uh, of their own research community. Also, on the aspect of not reducing, good researchers, I mean, we are a, country of 1.4 billion now. So yes, I mean, it wouldn't be, hard to expect that, we could certainly have Nobel Prize winners within us, which, who probably, did not get the chance to actually go to uh, the the kind of career they wanted to, because of, some constraints. Possibly they were also made engineers, they were made lawyers, right? Or they were made CAs. So I think one important thing that we also need to do in order to produce more quality researchers, as you say, is, make awareness about the fact that there is a very happening career in, STEM research as well. And if you want to become a researcher, or, if you have a knack for that, then it is not something which is bad to pursue. So I feel, that could eventually, give us a new crop of insanely talented researchers. But yeah, thank you for that.
Thank you. Thank you.
So I have this direct message from Professor Manish Srivastav. He is from Guru Ghasidas Vishwavidyalaya in Bilaspur, and he is asking that, how can we integrate these things in school curriculum? And Manish ji, thank you for this question. And in fact, that is something which I've been thinking about a lot as well. I think, one thing which is very important in this regard is to is to basically, give the students right from their high school years a taste of how research could be. And as as far-fetched as it might sound, it is not something which isn't happening worldwide. I mean, you have, people, like students in the US, in Europe, and stuff like that. They compete in things like the Interlicense, which is like uh, a science fair, uh, which is based on high school students presenting their research. The keyword is research, on international levels. And the best kind of stuff that we do in our school is stuff like Bal Vigyan. So like Bal Vigyan is just like a 1 month vacation for like students, where they just spend a month bunking classes and like have a good time and like present some kind of project and take a certificate. And no end product, no incentive is there eventually. So we are lagging behind, because like our students want to compete with those people who are doing research right from their 10th grade, let's say. But our students are being introduced to the idea of research in their masters. So like that 5 6 years of gap in those very important learning years for a student, of course, I'm not saying that people cannot make up for that gap in their PhD, but it is very hard to do so. And so I think if we introduce the notion and the likeliness of doing good research in high school itself, right? Then once the student has this idea that if I do this particular thing, then there is some incentive at the end of it. There is some light at the end of the tunnel. If the parents start to understand that भाई अगर हमारा बच्चा ये काम करेगा तो उसे appreciation मिलेगा, right? So eventually, people will be more open to it, and will be more focused on doing this kind of good work. I also have this question from Rohit Kumar, and he asks that why is there a resistance in India for theoretical physics as a career, which is a very good question, Rohit ji. And I think again, it all stems down to misconceptions. So some people, like when I talk to them, they're like, if you get into all of this stuff, you will have white hair at the age of 28, and you will have this very big hair, and you will just become Einstein. So the first question is, what is wrong with being Einstein? If you become Einstein, you will become one of the most recognized people of all time. I mean, till we are alive as a civilization, my name will be remembered if I become Einstein. But the thing is that people think somehow that people become mad after doing this kind of research and stuff like that. People also have this misconception about psychology as well, that if you read psychology, you will somehow become a psychotic person, which is like completely wrong, right? So I think the first thing is that we need to explain to both students and the parents of students and teachers as well, that like theoretical physics and mathematics is what as a field, right? And it is not something which makes you one dimensional, because I would also like to tell everyone this, that like for example, if you do a PhD in quantum field theory, it is not necessary that you will only become a professor. Rather, most people who do PhDs in quantum field theory, or like in the theoretical physics and mathematics, end up in finance. They end up in Goldman Sachs. They end up in places like McKinsey and stuff like that, and they become very they become people who drive Ferraris around, right? So if you become very good in math, then there is always that second option in life, that you can join finance and become some Wall Street banker. And I do not, and people will die for that career as a plan A, and and that career is your plan B, right? So like if these nitty-gritties are explained aptly to both students and teachers and to parents, then I think everybody would be more accepting of this idea of doing a research in this particular field.
Thank you, Omji. So also I have a question for you.
Sure.
So how do you see India contributing in the next age of cosmology? Matlab, can
Yeah.
ISRO become as big a contributor as NASA?
Yeah. Yeah, that's a very good question, Adarshi. So yeah, as I just mentioned to you, there are many, many cosmologists of Indian origin or from, from India who are doing very good work. And, I do feel that, like currently the big problems that we have in cosmology, problems of the early universe, problems of the late universe, like dark energy, dark matter, the Hubble tension as well. I do feel that whenever we get amicable solutions of these problems, there will be a big Indian hand in them. Uh, so I do feel on an individual level, Indian physicists will contribute eventually, and on a very big level. And I'm pretty sure that in the next 20-30 years, there will be like if you were to make a hall of fame of like big cosmologists, in the next 30 years, there will surely be a few Indian names in there worldwide. Regarding NASA and ISRO, I would say that ISRO is now on kind of like a good path towards going in that direction, because you see, for the last 10-15 years we were basically sending satellites, right? And that is something which is very nice, but that is something which is not as fundamental as as something which is being done by the European Space Agency, for example, or or by NASA, as you say. So while NASA is sending stuff like the James Webb Space Telescope, while European Space Agency is sending stuff like the Euclid probe, there was this need for ISRO to also do something which is not only constrained to our moon or to Mars or to stuff like that. While all of that is very cool, if you want to become on those levels of NASA and the European Space Agency, and the European Space Agency, you need to go beyond your solar system. You need to talk about the universe as a whole. And for example, India has now become a part of the Square Kilometer Array collaboration, which is like one of the big upcoming collaborations in astrophysics, and that has been done on the governmental levels. So that is quite a big thing. And I feel that if we can foster such collaborations more with ISRO, and if we can have a more open outlook on how we want to like foster international collaborations, get more people involved in what ISRO is doing, I think eventually we can pick up. But yeah, as of now, we would have to make up a lot of ground from the cosmological side.
Thank you, Omji. So, any more questions? So last question will be for me then. Okay,
Yeah.
so we see people like Richard Feynman, Carl Sagan, etc. So uh, become household names for any kid who like physics.
Yeah.
So, but why isn't the case with these, our Indian heroes, the names
Yeah.
which you just mentioned uh, in the presentation? So, do you reckon the situation will, change soon?
Yeah, so Adarshi, I will share this with you. So in the late 1970s, Carl Sagan had this very famous documentary series on his name, which is now very famous. It is The Cosmos by Carl Sagan, right? And
Mhm.
it had like 4 or 5 episodes, and it was initially aired only in the USA, but then it got aired in Canada, it got aired in Europe, it got aired across North America. Eventually, it got to places like Africa as well. And if you were to ask about the big scientific contributions of Carl Sagan, right? Then no offense, but like it was not on the levels of other big physicists, if you were to say. But that didn't deter him at all, because he was more of a science communicator, right? But with that massive influx of his documentaries everywhere, he became a more known name that than most working faces, uh, if I shall say like that. Then you have people like Richard Feynman. When he won the Nobel Prize in 1964 for his work with independently with Julian Schwinger and Tomonaga. Schwinger was a very private person. So, there was not much, stuff about him. Tomonaga was also, like known in his circles in Japan. But Feynman, again, he got loads of interviews. He got a movie. He actually had two movies on him, right? And those movies got, publicized across the world. So in that sense, what we see is that, people celebrate their heroes. And for example, if you like of the 12 of the 13 people out of whom I have shared about you today, I can easily say that if someone like Akshay Kumar was to make a biopic on like any of like one of them, the movie will be a 100 crore movie for sure, because the stories of these people are incredible. I mean, if you read about them, you get inspired to insane levels. And I would say that the USA does this very well. The UK does this very well. I wouldn't say this about the other European countries, but these two countries do it very well. If they have an incredible mind, they know how to appreciate it. And so, if I think the situation in India can change, because there are loads of students who want to understand theoretical physics and stuff like that. I was like one of them, of course, and I was also just completely indulged in watching documentaries. But what I would say is that if we also start making documentaries on our own people, and documentaries which are of of a global standard, then I think our people will not only be more known in India but also abroad, and I think they deserve it, of course, in every sense of the word.
Thank you, thank you. So I personally don't think there are other questions left. So thank you so much, Omji, for enlightening us. And I would also like to thank our audience for being here for this patient learning and patient listening. So again, I would like to repeat about the India Academy program. So India Academy is being set up with the purpose of grassroots mobilization of teachers and academicians in all subject areas with the goal of strengthening India's education system. So we will again come up and with another enlightened guest. Hope we will get the same amount of love like today. Thank you once again to everyone, especially Omji. So Om
Thank you,
Trivedi ji, thank
Adarshi.
you.
Thank you, Adarshi, again for this invite, and it was quite an honor and a great opportunity to possibly talk about those people who need to be talked about. And thank you again to you and to Rajiv ji for the invite.
Thank you. Thank you. Thank you, everyone. Namaste. Jai.